Stan Gibilisco here. A viewer recently asked me if I knew how universal power adapters work. And I'm assuming now that what he was talking about was a device for charging something like a cell phone or a tablet computer or any kind of small device like that from an AC source that comes from power source from generators in a foreign country or an unfamiliar country. Generally speaking, in the United States, we have 120 volts RMS AC at 60 hertz. But that is not always the case, of course, in other countries in the world. A lot of times the alternative voltages are roughly 220 to 240 volts, and sometimes 50 hertz rather than 60 hertz. Well, I don't know exactly how these things work. I've never broken one apart, and I don't believe that anyone who makes a good one would reveal their circuit design to anyone. You'd have to reverse engineer the thing, and I'm not about to try and do that. What I thought, though, was that this is the way I would approach it as an engineer myself. Here is your AC source, and it is not necessarily 120 volts at 60 hertz. In fact, it is one of these other sources. Most of the world, I believe, uses the higher voltage. I guess the objective is for a given amount of power, you have to draw less current, so you can it produces less current in the wire and therefore less heating in the wires. But of course, the higher voltage is more dangerous. Now, the 50 hertz or 60 hertz is a little less important if you're going to convert to DC in the final result. So what I would do is I would have an electronic transformer, a solid state version of some kind of transformer that transforms down to the charging voltage that you need for your device. And in order to obtain that voltage, you're going to have a microprocessor. And you're going to have to tell that microprocessor what unit you want to charge. Say, for example, maybe it's like my Surface Pro. I believe it's called the Surface Pro 2. You tell the microprocessor that it has a whole bunch of devices pre-programmed in it, so it will program this electronic transformer, and then there's a sensor in this microprocessor that senses what the voltage at the input actually is and what the frequency is, so that this electronic transformer will convert using this AC to DC converter to the proper voltage to charge your unit, and also the proper current delivering or charging rate capability. I guess I should include then here another connection. The microprocessor is going to have to communicate with this AC to DC converter, so that when you tell it what device you want to use, it tells the transformer what transformation ratio to use to get the proper voltage for this thing, which will then provide the appropriate amount of charging parameters for your particular device. Now, that is the way that I would go about designing something like that. And when he talks about a power adapter, I'm assuming that that's what he means. I'm not assuming that he means that you want to convert some foreign alternating current source into 120 volts AC at 60 hertz. You can. You would have to add an extra circuit to the mix, and that would be a power inverter. You know those things. Power inverter is something that takes, say, 12 volts DC from your automobile and converts it to 60 hertz 120 volts AC by means of a chopper and some solid state circuitry and a transformer and things like that. I'm assuming, though, that he's not talking about that. I'm assuming that he wants to get DC at the output of the appropriate charging parameters for any particular popular device and any particular popular country in the world. And the microprocessor can have all that information in it. That, I think, is the core of this device. It's a smart device, and the reason is it's a smart microprocessor. That would be my approach to designing a universal power adapter. But as I've said, I don't really know the proprietary designs of various manufacturers out there, and I suppose they don't want you to know either. With that, I will sign off. Until next time, so long.